Hello, welcome to ANS Solver. This is the fifth question of the paper. So I need to differentiate 1 over sine square theta with respect to theta. So basically I can write this as 1 over sine theta the whole raised to 2, which can be written as sine theta the whole raised to minus 2. Now basically I need to differentiate this. Okay, I need to differentiate this. So, how do I differentiate something like this in the respect of theta? D by d theta, correct? Which is now equal to, first, to differentiate something like this, I take the outer bracket first. So basically, I write this as minus 2 sine theta raised to minus 2 minus 1. But now, because there's a bracket, the chain rule will apply and the differentiation of sine theta will be multiplied. The differentiation of sine theta is cos theta. Okay, so now I get minus 2 sine theta raised to minus 3 into cos theta, which I can basically write as minus 2 cos theta over sine theta raised to 3, which basically can be written as minus 2 cos theta over sine cube theta, which is basically the final answer of the question. Okay, the variable x and theta satisfy this differential equation. I have been given that x is equal to 4, theta is equal to 1 over 6 pi, and I need to solve this differential equation and obtain x in terms of theta. So first, I can basically write this as theta here. I can basically rearrange this and write this as x tan theta dx by d theta, okay, equals to minus cos x square theta. Okay, now what I can simply do is I can write this as x dx. This is called the variable separable form, where basically I'm keeping my thetas together, okay, and my x's together. So now I know this can be written as x dx equals to, I know minus cos x square theta can be written as minus 1 over sine square theta over sine theta over cos theta d theta. Got it? So now I can simply write this as x dx equals to minus 1 over sine square theta divided by sine theta over cos theta d theta, which can be written as x dx equals to minus 1 over sine theta the whole square into cos theta over sine theta d theta. Now I can write this as x dx equals to, the multiplication of this will give me minus cos theta over sine cube theta d theta. Got it? So now what I simply do is I can integrate both sides. So now I can split this into parts here. The integration of x will basically be x raised to 1 plus 1 over 1 plus 1, which will give me x square over 2. Correct? Now, if you go to your part A, we had got cos theta over sine cube theta here, but there was a 2. So I can even say that, because see, here you need to know that your differentiation, okay, dy by dx and integration work in reverse ways. In the A part we differentiated. So now if I integrate this, okay, I'll basically get 1 over sine square theta, but there will be a 2. So I'll basically get 1 over 2 sine square theta when I integrate this, because integration and differentiation work in reverse mechanisms. So yeah, okay, this is what I get. Now what I do is when I integrate this, I know there's no limit, so there's a plus c. So I can write this basically as x square over 2 equals to 1 over 2 sine square theta plus c. So now I know my theta and my x, the values are given. Theta is 1 over 6 pi and x is 4. So theta is 1 over 6 pi and my x is 4. So I can simply substitute here. 4 square over 2 equals to 1 over 2 sine square 1 over 6 pi plus c. So I'm basically finding c here. So this is 4 square over 2, which gives me 8 equals to, now if you do sine of, now you need to maintain in the radian mode. So when you do sine of 1 over 6 pi, you get 1 over 2, and the square of that gives me 1 over 4, and when it's basically multiplied by 2, I get 1 over 2. So 1 over 2 plus c, which I can write as 8 equals to 2 plus c, which basically can be written as c equals to 8 minus 2, which is 6. So now I can basically write this as x square by 2 equals to 1 over 2 sine square theta, okay, plus 6. Got it? Now what I can do is I can write this as x square equals to 2 into, this can basically be written as 1 over 2 cosec square theta, correct? Because 1 over cosec theta, or sorry, 1 over sine theta is cosec theta, correct? Plus 6. So now I can basically write this as x square equals to, I can take 2 inside to get cosec square theta plus 2 into 6, which gives me 12. So I can basically write this as the square root of cosec square theta plus 12, which is basically x in terms of theta, which dad asked. So the important thing here is basic derivation. You need to know this works, dy by dx works in the opposite direction, correct? And the 2 you need to account here for, correct? Or else everything else was simple in this question.